Alright, let's evaluate the following limit, and here we can see another variation of these limit type questions, but this time we actually have an absolute value associated with it. Now by looking at the limit, you can notice here that as limit as x approaches 2, on the denominator this is actually going to start to approach 0, right? So whenever the denominator is 0 on a rational expression, this implies there's a restriction. So if there's a restriction, then this whole thing will become undefined. So we need a way to cancel out the x minus 2. So I'm going to take a look at the rational expression, and specifically the numerator. We have an x minus 2 in an absolute value bracket, right? So the absolute value just implies that we're just looking at the positive magnitude, right? But there's going to be two values of x minus 2 on the inside, right? So if you look at x minus 2, right, if we look at x minus 2, if we're looking at the positive value, right, and the absolute value means that the inside can be positive or negative, if you're looking at the positive value, then x is going to be greater than 2. So we're going to actually get positive x minus 2 when x is greater than 2. Right, and vice versa, if you have x minus 2 less than 0, right, if I move the negative 2 here, we get x is less than 2, so we're going to get negative x minus 2 when x is less than 2, right? In both of these cases, when you put them into the absolute value bracket, you'll still get x minus 2 because that's the magnitude. Now that we have this, I'm going to apply this to the limit expression, right? So we're going to have two different values. Right, so the way I'm going to look at this, I'm going to have positive x minus 2 over x minus 2 on the denominator, limit x approaches 2, when x is greater than 2, right? And you can notice here that if I do solve for this, these are common factors, they cancel out, and you basically get limit as x approaches 2 to 1, right? So we basically get the limit of any constant is the constant, so we're going to get the value of 1, right? So as x approaches 2, this whole thing will still approach 1. In the other case, limit as x approaches 2, when x is less than 2, then we're going to get negative x minus 2 over x minus 2. The two common factors would cancel out, and we're basically going to get limit as x approaches 2 of negative 1, and this will give us negative 1. So you can see that there's going to be two different answers at these two different intervals, right? So that's basically how you would solve one of these absolute value type limit questions.